We talked before about the TCR workflow, test and commit or revert. Basically, you start from a green version, passing to all tests. You write some new code. It could be test and production code, or it could be refactoring, structural changes. Either way, you run the tests. If they run red, you revert and try again. If they run green, you commit and go on to the next action. We're repeating an example Kent Beck did a few weeks ago where you take the substring of a left string plus a right string from the start to the stop positions. For example, if you have A, B, C, and D, E, F, from 4 to 4 is an empty string, from 0 to 6 is the whole string, A, B, C, D, E, F, and from 1 to 4 is B, C, D, taking the first two characters from the left string and the last one from the right string. We have a constraint in our solution. We don't want to build left plus right unless that's the answer. It causes performance problems and creates garbage. You can look at strings as using an array index where A is in slot 0, B is in slot 1. But for this kind of problem, it's actually easier to use the gap index. There's a gap at position 0, gap 0 in front of the A, gap 1 between A and B. Or you can think of that as the number of characters to the left of the index. So gap index 2 has two characters to the left of it, A and B. When I first saw Kent's solution, I had a couple ideas for design alternatives. We looked at one last time where you build left plus right early on, even though the constraints say the final solution can't have it. The other one that occurred to me was something I have learned to call the direct representation, where the function calls you're making almost serve as the definition of the objects involved. So I sketched out this design. I'm going to have some sort of myString class. It could be empty. It could be a simple string, which might be a substring of another string and builds off a Java string. Or it might be a compound string of some sort, which takes two myStrings as arguments. So the myCompound string will help us build the left plus right, and the simple string will let us get the ranges. Let's go ahead and use that design idea as the starting point. So I went over to the documentation for the string class and noticed right away, even though I was going to look in substrings and so on, I noticed this charsequence interface used right away. Charsequence is a way to kind of unify the difference between strings and string buffers and other string-like objects. Because strings are char sequences, it's nice. They give us a way to have substrings of things. So I think we'll definitely want to make use of that. If you go look at that interface, it's got 4 methods. One to get the character at a position, one to get the length, one to get a subsequence, and one to get the toString value. The interesting method of these is subsequence. It takes the start and end position, just like our example is going to, and it returns another char sequence. So we'll be able to make use of this. And let's go implement a solution. Okay, for starters, I've just created a minimal project with one test in it. It asserts that 10 equals 10 just to get things going. And we can run that test. And we're good. Now I'm using this limited whip plugin. It's in IntelliJ, and basically when a test passes, it's going to commit, and it'll use the last commit message. So it will revert when we run tests and they turn out red. Let's demonstrate that. Let's assert 10 equals 0. Okay, notice it turned this back into 10 and 10 and put us back where we were. So any little mistake, refactoring or adding code, reverts. For starters, we have the idea of myString with the subclasses, myEmptyString, mySimpleString, and myCompoundString. I think the simple string will be the one to start with. The empty one I think will be pretty trivial when we get there. So let's do that. Let's make probably the easiest thing we can do is just get the toString on that thing. So let's assert that the toString is ABC, and the actual is going to be s.toString. Well, and we'll start with myString. So I'm envisioning this type as a wrapper for a Java string. And eventually we'll get the indexes in there, but I think we'll get the shape of things out there first. So I've got the myString class. It's going to take ABC. When I ask for its toString value, I expect ABC back. And let's just build this class. And we'll leave it in here. We'll leave the source. Okay, add this thing to get. Okay, and we know he's going to need a constructor. Create that constructor with string, say raw, and we'll generate that field. And then we want his toString to just return raw. Okay, so I'm just returning the string I wrap, and he's doing that. Now, eventually we want to be a char sequence, but this will get us started. So my string wraps a Java string. We expect it to pass. And it does. Okay, another thing we know we need is a char at. So let's just get the character to position, or let's get the length. Okay. Create the method. We want int length, and you might be used to the TDD style where you return something that fails, but in our case, we're trying to do the real thing. So we'll just do a pass-through method on the raw length, and I expect this to pass. Okay, very good. Another one we needed is that char at. So let's just ask if it knows char at. So character A is in position 0. So this one we're using the character index, the array index of things. Okay, this method doesn't yet exist. Returns a char, int I. Okay, we can live with that. Return raw.char at I. And should pass. All right, and then that fourth method is the subsequence. So let's make sure that if we take the subsequence, let's make sure we get this thing right. Subsequence. Okay, if we take s.subsequence from position 1, gap 1 to gap 3, so 1 character to the left to 3 characters to the left, we expect the BC. And this method, notice we want to get charsequence in there so that we're conforming. So this is from and to. And again, we're just passing things through for now. Okay, run those tests. Okay, so now we have my string is implementing all 4 methods needed to be a subsequence. So I should be able to say this is a subsequence. Whoops, charsequence. But it can't quite be that yet because it doesn't implement that interface. But we're already doing all the methods for that, so we're okay. Sequence. Okay, now my intent was this was going to be simple string. I was thinking my string for the parent class, but now that I'm looking at it, it doesn't really. We don't really need a parent class because we're already acting like a char sequence, and that's what we often pass around. But the whole point of this design is going to be that we're going to try and avoid evaluating left plus right until the very end. So it's passing back the string. We're actually computing the subsequence from it, kind of on demand. And that's okay for now, I think. We'll see how that comes out. But it does sort of tell me like the myString parent class might not be needed because we've already got this char sequence interface that supports it. And I don't know there may be a better name for this thing. We'll see what happens when we get there. Okay, that one came out pretty quick. All the methods are basically pass-throughs to the Java string class, so there's not much going on there. Where I think it'll get more interesting is the subsequences. I think we have an opportunity to do things a little differently, but I'm not going to worry about that. I'm going to once again try and push through and get this thing working, even though it's not as efficient as I want. So my next set of tests, they're going to be for the compound string. I'll say it works with substrings. And again, I'm kind of just trying to get the shape of things in place. So we'll make a my compound string. It's a new my compound string. And my thought was he was going to take my sequences. I could let him take my strings, but I think the right thing is really to take char sequences. And they could be a my string, or they could just be a simple string, or it could be a string buffer or something else. I think that'll let us work with this. So we'll mix up the sizes at least a little bit. So I've got my compound string class, and again, I'm going to start very simply. And if you ask for toString on this thing, you ought to get one. Okay, so let's build the class. There's my compound class. Yeah, we'll take that. He needs a constructor. This is left and right, but we said these are really char sequences. And char sequence, right? Didn't know that worked that way. Okay, char sequence and right. Okay, and we'll go ahead and capture these. The toString, and we can just do left plus right. I guess left.toString plus right.toString. Okay, so if you ask for a string with A, B, and C, D, E, F, you should get that string as the total string. Okay. And the length is easy enough. The length is S's length. We'll test. Okay, so far I'm feeling good. I haven't had to revert yet. I shouldn't say anything, right? Okay, now let's take a character position. Let's see. If we took a character at position 1, we'd get a B back. Okay, so position 0, position 1 is the B. We have to add the method. We'll just do left char at I for a moment. Not a complete implementation, but just kind of getting pieces in. Okay. Let's get the C because it's on the other side. It's on the right-hand string. So char at 2. And over here in the compound string, if I is less than the left string length, okay, so we want to, when it's less than the length of the left-hand string, we'll use that index. And otherwise, we're going to do right.char at, and we can't use I straight up because our right-hand string starts at 0, and we've already got the index already goes outside that. So let's take off the left length. Run the tests. Okay, so now the compound string is doing a little bit of work. It's got to keep track of that size of that left-hand string and adjust its indexes to work properly. And then the final one is the subsequence. And we'll go for BC again. If we take S subsequence from position, let's take 1 to 3, like we did before. Okay. And run tests. It doesn't compile, so I don't think the TCR thing kicks in just yet. Create the method, returns a string, index from, index to. But we will just do, I think for now we'll just do toString subsequence from and to. To make that work, this thing has to be a charsequence. Okay. Okay, so that test runs as well. So I'm pretty happy at this point. We haven't really needed that parent class, and I think in the end we don't really need it, since the interesting stuff is either everything's returning either a primitive, like a char or int, or a string, almost primitive, or it's returning a subsequence, but because subsequence is already compatible with string and it's compatible with our class, I don't think we have to do any extra work for that. The places where we're not quite there, right now we're doing this left plus right. We're not happy with that because it's going to evaluate right away. And to compute left and right, basically it's building up that whole string. This is the point where we can switch over to take advantage of subsequences. But what I'm going to do first is I want to harden this thing a little bit. Basically for the subsequences, I want to make sure things are in range. So when you ask for a subsequence from a position to a position, if your from is less than 0, we're going to make it 0. If your to is greater than the length of the string, we're going to limit it. Really what I want to do is I'd like to make my strings a little smarter. I'd like them to know what positions in the Java string they're going to get. I think I can make that happen with the constructor. I guess I still need to worry about the subsequence. Right now I'm relying on the substring to do that. Let's handle ranges in here and see what happens from that. Add another test for my my string. How about my string can adjust boundaries? Let's say I have a string. I think it's going to sound the same once I build it. My string is my string, and let's take a large string, A, B, C, D, E, F. Let's add a character we're going to filter out. 0 there. So we're going to try and catch the string that's in the middle. So instead of starting at index gap index 0, we're going to start at gap index 1. So I'm going to add an extra parameter here that represents the starting position on the string that we're working with, the raw string. This last position, there's 7 characters to the left because I've got the underscore in there still. Okay, so we'll need a new constructor. Create it. Okay. This is the raw string. This is start and stop. Okay, I can see I'm already being inconsistent here. And let's capture these. We'll catch all those fields. And so this, just to get things compiling again, this should be 0 and raw.length. Okay, so I'm saying if you just give me a plain old string, I'm assuming it's the whole string. If you give me a string and some indexes, I'll restrict it to the indexes you say. Okay, but I'm going to have to adjust things. And it actually, well, do we have to do one at a time? I guess let's see what our assertions are. So the toString, we expect A, B, C, D, E, F out of s.toString. Okay, so how can I make that happen? Well, normally toString just does raw, but I can do the substring kind of the same way, start to stop. So before we did a simple string, just returned it. Now we're going to keep track of the substring of the string we're starting with. And let's just return that. The length, well, we don't have to compute that. I think we've gone far enough. I think the test will still work. I don't know. I'd be writing some things on my card at this point. We've got some outstanding work to do. Okay, so that passes. Let's get the length. We'll just catch these methods one at a time. So they work for the first test because it just always assumed you had the whole string. Now we're going to do a method at a time to make sure it wants the string, that it finds that substring and works with that. So let's do the length. The length is 6. We want the ABCDEF out of s.length. Okay. And length, raw.length, well, it's really stop minus start, I think. So before the raw length, this will still work because this case it's length minus 0, and the other cases it's stop minus start. So I think this will work. Okay, yeah, so I feel like we're kind of on a good track there. All right, the char at. Okay, in this case, when you ask for the character to position, if you ask for position 0, you're not going to get the underscore. We want you to get the A. So let's make sure that's in there. Char at 0. Now we think this would fail. Yeah, normally it's starting off of raw char at 0, so we need to subtract off the start. Okay, so if you ask for 0, let's do plus. If your start is 1 and we ask for slot 0, we want to make sure we're getting the 1 that you're getting. So rather than argue myself into it for a little while, let's just run the test and let it tell us. Right, yeah, now it'd be easy to get the pluses and minuses wrong. Let's move this here. But also that makes me realize like my test data probably could be better. So I have that underscore. Let's add another character so that the start, the characters to the left that we're ignoring is just 1, and to the right we're ignoring 2. I think that will make us just a little more safe in case we met stop and we put start and things like that. Okay, now our subsequence. Let's try and get the BC again. So, well, let's get BCD again. Just kind of mixing up the data a little bit. Subsequence from 1 to 4. Okay, again, it's the gap, and we have to adjust off the start first and then pull. This is gap 1 of the ABC through gap 4, the DEF. Okay. Now, this is where I'm going to get a little fancy. Okay, if you gave me a subsequence, I don't have to return it right now. I don't have to do the work right now. Again, I'm kind of trying to defer work until somebody really needs it. And then I'm going to start appending and trimming and things like that. I think what I want to say is this is new my string. We'll start with raw. And I want to say from and to, but they have to be adjusted. If you're asked for a subsequence, don't just return it. Build it as another request to a my string. And then the from, again, we need to adjust things. From.start or from plus start. So if you asked for 0 and you went off raw, that would be wrong. You have to adjust it from start. And then I think this one is also from start. Oh, subtle. Okay, we expected BC, but we got BC. And we got reverted. Okay, we'll try again. We're expecting to see BCD if we take S subsequence. We said it's not 0, it's 1 through 4. So we want 1 to represent the position between A and B, and 4 to represent the position between D and E. I think that the problem was we returned a my string, but we really need to ask what's your string value. So we had BC versus BC, and I think the problem was one's a string, one's a my string, and they just don't compare equals for free. But if I convert it off to back to a string, I guarantee that it is a string, a Java string, not a my string. All right, and so well, one interesting thing there is we found a problem in our test. So it's easy to look at this versus TDD and say, well, it never tests your tests, but there we got one. Unfortunately, it tested it by failing on me, but we'll live with that. Okay, so before we had my string, we had raw, our starting point, and then from plus start and to plus start. I still think there's something off here. Like, does this really need to be a string? I feel like that could be a char sequence. Let's see if this test passes. Okay, now we broke this one. Again, oh, BC versus BC, same problem. Okay, so let's make this toString. Let's be proactive here, make this toString. And add our test in one more time, I hope. BCD should be string subsequence of 1 to 4. My string of raw from plus start to plus start. Oh. Did I forget it on the middle one again? Okay, let's make sure this runs. Okay, take a smaller byte. And this should be toString. Okay, so I find myself doing things to lock it in. So I know this should be toString. Let's get that taken care of. I wasn't watching well enough to know. I think I left out a toString. BCD S dot subsequence of 1 to 4. Yeah, dot toString. I think I did leave that off. You'd think I'd be good at typing this by now. Raw from plus start to plus start. You're probably thinking, how many times can that guy type that one thing over and over? But we're there. Okay, so let's see. From implementation then, all right. It's like, do I care that raw is a string? I don't think I do. I think he should be able to be a char sequence. A substring. I think I can do this. He doesn't like char sequence there because this should be okay with a char sequence, and I think this one should. Run those tests. Okay, so I'm becoming more independent. So now I can stack up char sequences, my strings on my strings. Everything's going to be compatible. The only thing I don't like is this. Okay, so we want to think about, is this the moment we want to calculate the actual string? And I think it is. When you say you're going to give the string, then that should be enough. But we don't want to have you articulate your whole string when we just want a substring of it. Okay, so I think we'll want to redo that one. But I think this one's going to be the way it is. So when you ask for a subsequence, we just peel off a new string for that sequence. And it's this one that we don't want to do that for. So let's make sure they run. Okay, so I think what I'm going to do then is make a string buffer. And let's do this. I equals start. I less than stop. I plus plus. We're going to do result dot append raw char at I. And then we're going to return result.toString. Now, do I need to make any adjustments? I guess I'll do it by testing. It's funny how jealous you get about 5 lines of code. Okay, so that seems okay. So I'm saying if I want this stuff from 0 to 3, I'm doing less than the stop. Okay, so now if I took a huge Java string, passed it in, and said, give me character 2, I'm not going to call toString and get that giant string, rebuild it. I'm just going to pull out character 2 myself and take it. All right, so I'm happy with that. Now the place I want to worry is kind of boundary conditions. If the index is out of bounds, we're supposed to throw an exception. And I guess the 2 places that counts is char at. Okay, so if I do char at, I'm asking for another level's char at. I think I can rely on it to throw the exception if it needs to. But there's a constraint on subsequence. If the indexes are out of range, it really should throw an exception there. And since I'm relying on this thing, I guess I'm saying if these things are out of range, then we're going to throw this index out of bounds exception. So let's test that. Okay, so we'll deal with the exceptions case. All right, so my string throws exception if range is invalid. And I'll admit I had to look this syntax up. Assert throws. Okay, I have to have the class. Out of bounds exception class. And a code fragment. Let's do something negative here. Okay, so it's legitimate on the right-hand side, but not the left-hand side. Well, I guess they insist on their formatting. Okay, let's run this test. Oh, well, let's not run it because I don't think that's going to work unless I put some assertions in here. So this is on the start. If the start is less than 0, then we're going to throw new index out of bounds exceptions. I think that'll be true. And I think it won't be too confusing if I put both tests in here. So this one's okay, but if the other one is bigger than the range, then that's a problem. So if the stop is greater than the length, okay, and then the last thing that can go wrong the stop is less than the start. It can be equal because that would just be an empty string. So if the stop is less than the start, we'll throw one more. Okay, yeah, I think this is good. So if we ask for a substring, a subsequence, and we create a new substring that takes care of those things, it'll deal with the fact if the bounds go bad. Okay, so subsequence will meet its contract of reporting errors when the ranges are wrong. Okay, so what about my compound string? Well, okay, so toString will trust left plus right length. Okay, these already take char sequences, so that's good. Okay, if it's less than the left length, we're going to ask for a char hat I. That's fine. So if it's less than 0, it's going to become the char at will take care of it. If it's too big, even if we subtract off the length, this thing will be too big, and again, char at will take care of it. And then for a subsequence, again, we're relying on somebody else's doing their job for the range. Okay, now the big finish, although it'll be a little slow here, I think, but we're trying to avoid appending the strings unless we have to. Okay, when you ask for the substring, we have the left and right string, we pretty much have to give it back. If we had substrings that we're not computing until they had to, that would be okay. So I think the question is going to be then when we catch it's really the toString that's the problem. So on a subsequence, we would rather not calculate the actual value until somebody really calls for it. I think we're going to try and push all the work down onto the my string with the range management. We just have to worry about the split point. In a way, I think there's 3 cases. One case is where from and to are completely less than the split point, or less than or equal. The other where they're both greater than the split point. And the third is when you cross things. So I think we have something working in place, but we don't have enough test cases for those situations. So what we're going to want to do is, if everything's on the left string, we'll just build a simple string and return it as the subsequence. It won't evaluate until it's done all its work, but we certainly don't have to articulate the whole string. Same thing on the right string, but if it's left and right pieces, we're going to pull out the pieces and make a new compound string from those. Okay, so let's make some test cases. And this is the part I'm really hoping works out nicely. Okay, so we shall see. So my compound string finds subsequence on left string only. Okay, so we'll build a compound string. S is new. And I think we can get by with a little shorter string. Okay, so if I ask this thing for charsequence sub is s dot subsequence from 0 to 1, and I guess I'm going to assert that that sequence should be just A if I do sub dot toString. See, I can remember it once in a while. All right, now I think this should already work, so let's make sure that the test is good. And it works at this performance cost, which is fine. I don't think I need this here. Oops. Is it in? Yes. Okay. And we'll want the corresponding test. On the right side. And let's expect to only pull C if we take the subsequence from 2 characters to the left up to 3. And again, it should just work. So I feel like that the fact that we're doing sort of the inefficient solution here of actually articulating the substring before somebody calls it on the toString on the little piece we want. It's not as efficient as we want, but it works for now. So we can get the tests in place and reassure ourselves. Finds a subsequence built from both strings. So let's go for A, B. That's 0 to the left and 2 on the other end. And again, I think my test will pin down this current solution. Okay, now we can be fancy. Okay, let's peel off the case where the left substring is the only thing we care about. So if 2 is less than or equal to the left length, let's try doing this in the right file just for grins. If the 2 is less than or equal to left length. Okay, and I guess I'm assuming that from is, and if it's not, it'll blow up when we make the restriction. If you want the from and the to, then I'm going to say return new myString with the left string only and from and to. Okay, so you're only pulling out of the left string, then let's just return that string by itself and restrict it to the range we want. Nice, gives me some confidence. All right, the next case is the from is greater than or equal to the left length. Okay, so our starting point is inside that right-hand string. Then we're going to return a new string. This is the right string from minus the left-hand length and to minus the left-hand length. Feels like a somewhat big step. Good. Okay, we can certainly refactor that. Let's see, is this, nope. It's variable. Let's get all those and we'll call it left length. Okay, so those are good. Now we got this last case where you split strings. Oops. Okay, so we're going to return, it's going to be a myString. This time we need 2 strings, so we're going to need something from the left. We'll need something from the left and something from the right. We're going to only pull from the left. Okay, so this is going to be a compound string. It's going to take 2 substrings that are going to be myStrings. And since it needs something from the left, we'll build from the left. His from should be safe. His to, the biggest, well, let's see. I think we're going to want the minimum. We're going to look at the right-hand length, the left length. So if it's bigger than left length, which it apparently is, actually we know it is, so I guess we don't even need to do any calculation here. So we're basically taking from the start, from the from point on the left-hand side through its length, and then on this string, we're going to take the right, his starting point is left length, well, no, his starting point is 0. And his ending point, the 2 is on the whole string, so we have to subtract off left length. Okay, and what have I done wrong? Required a char sequence. Oh, I never said I was a char sequence. Let's hope I am. it felt like I had to do some convincing for myself, but it looks like we're good. So let's take a look here. Let's clean up as we go. Okay, so the key thing is this method here, I think. It's the thing that's going to defer the implementation. So if the 2-point is less than or equal to the left length, then we're pulling a string fully from the left side. We'll just do that. If it's greater than the left, if the from is greater than or equal to the left length, then we're pulling just from the right-hand side. Otherwise, we know we're pulling something that touches left and right. Okay, and on the left side, it's going to start at from, because we know that's less, and it's going to go up to the length of the string because we know the whole right-hand part of the left-hand string will be there, and then we're peeling off the right-hand string from 0 up to how many characters are left once we've adjusted it. Okay, and okay, so I guess one question is, do we throw exceptions where we need to? And I believe we can convince ourselves the answer is yes, because my string constructor throws those exceptions if it has to, and everything is going through a path with my string in it. If from and to were crossed at some point, we would hit one of these cases where you're calling my string. So I think that's fine. Okay, so left and right. Then the two strings, when we get around to those little pieces, we've just got the little substrings. Okay, left and right got adjusted if they're compound strings. So that one is only pulling characters it needs to. The length, we're just asking the two parts. Char@, we're calling char@ on each path, so I think it should throw when it needs to. And then this thing is okay. Now, you might wonder why I'm not having from and to on the constructor here. And the answer is I've delegated that work off. Down in here, I'm pushing all that stuff to my string. I've done the work to figure out which one of these gets called and how to adjust it, but my string can do the work of actually restricting the range. I want to just do one more test, and I fully well, let's check in, run these tests first. Okay, so this last test, it's the example we wanted from the very beginning. I guess I'm going to do how about a complex string finds its value. Okay, so we're going to take a compound string. Well, let's take a my string, and he's, let's see, rs. We're going to take a my string built out of a compound string. Compound string is AB. This string is CDEF. Okay, but the range, let's just take 1 and 4. So we're going to take a my string built out of a compound string and only pull positions 1 and 4. And we're going to say that thing should equal whoops. Oh, huh. You can tell I was doing C# last week. It's .toString. So we'll build a compound string 1 to 4 and only pull out a substring of its characters. Basically, I'm trying to prove that we can grab this thing without ever appending the whole big string. So let's run this test. Basically, I think this is working out pretty well. So if I really needed to be careful about the performance, I can I could do some sort of maybe deconstruction in here and try and figure out what my subsequences were and really track them through, at least from a functional behavior point of view. I think we've got this thing right. When you ask for toString, let's see. So when we ask myString for toString, he's not gonna ask the big string for its characters. He's just gonna go in there and ask for characters at a position. So we never call toString on raw. Okay. Since we never call toString on raw, even if raw is very big and very complex, we're only going in there and saying, give me the right characters. And the right characters come in because we've made the adjustments based on that split point. We never have to build the big string. So in that sense, I'm pretty happy with things. I think I want to say lazy compound string. Sorry, lazy char sequence. This one isn't even the compound. Lazy because it doesn't pull things out until it has to. And then I don't quite know the right name here, but it's built from 2, so I'm just going to go with that for now. You might have a better suggestion for me, but a string built from 2 things, I'll call it lazy char sequence 2. I think that reflects the way I want things to be. And the only one left is that empty string. And originally I thought it would be a separate class, but now, you're just returning it. If you pass in an empty string, it's going to be 0 with a length of 0. ToString's not going to have not have anything added to the string buffer. The length is 0. The character at will blow up like it should. Subsequence will blow up. So I don't think there's any point to that one either. And so the design ended up quite a bit different than I thought. I think the essence is there that if you build character sequences from the lazy char sequence and the lazy char sequence 2, now they can build from char sequences, any including themselves. They both implement that interface. If you build things out of the lazy strings, everything works together. They don't pull any unnecessary string appends or anything like that. So I think that's a good win. The design is definitely simpler than I thought it would be. I think it's very nice, very pretty, and does the job, which is even more important. All right, if you'd like to learn more about TCR, Kent Beck wrote an article about it, describing how he discovered it or worked it out with some friends at a workshop. I wrote a little bit a few weeks ago about TCR and commits, and I also made the earlier demo video. That one shows finding the substring by appending the big string and then slowly working towards a more optimized implementation. All right, if you like work like this, I'm on XP123 where my articles are, or support me on Patreon. Thank you very much.